Have you ever stopped to think about what keeps our world spinning? No, I mean that literally. From a massive wind turbine powering your city to the tiny fan inside your laptop, there is one single, ingenious little component at the heart of almost everything that moves. Today, we're finally going to put that unsung hero right in the spotlight.
So, let's start with a bit of a puzzle. Picture this. On one hand, you've got a 70-ton piece of industrial machinery, right? Battling incredible forces out in the elements. And on the other hand, you have the delicate, complex joint that lets you walk, run, and jump. What on earth could those two possibly have in common?
Well, the answer is that they both rely on the exact same brilliant principle. It's a principle brought to life by one of engineering's most critical and most overlooked inventions. It's a component that is literally everywhere, but you almost never, ever see it.
We are talking about the bearing. And what it does is actually pretty simple, but it's pure genius. A bearing does two things perfectly. One, it makes sure things only move the way you want them to. And two, and this is the big one, it wages a constant all-out war against friction.
And believe me, that battle against friction is everything. You see, friction is this universal force that just wants to grind all motion to a stop. It creates heat, it causes parts to wear out, and it wastes a staggering amount of energy. Bearings? They're our secret weapon to defeat it.
To really get it, just think about moving a heavy box. If you drag it across the floor, you're dealing with sliding friction. It's tough, it's inefficient, you're scraping up the floor. But what if you put that same box on a few wheels? All of a sudden, you've replaced all that sliding with rolling. The resistance just plummets. That right there is the fundamental magic of a roller bearing. It turns that awful, high-energy sliding into smooth, low-energy roll.
And by conquering friction, by winning that battle, bearings have allowed us to build our world on a truly monumental scale. Seriously, you can think of them as the invisible joints and muscles of our entire industrial planet.
And you will find them everywhere. They're inside the axle boxes of high-speed trains, making sure the ride is smooth and safe. They're deep inside diesel engines, taking on insane pressures in the crankshafts. They're at the very heart of pretty much every electric motor on the planet, where they're actually a surprisingly vulnerable part.
And the stakes? They're incredibly high. Take a single 1.5 megawatt wind turbine. It's got these massive blades supported by a very specific part, a double-row spherical roller bearing. If the lubrication on that one single component fails, the entire multi-million-dollar turbine can suffer a catastrophic breakdown. Our power grid is literally resting on these things working perfectly.
Okay, but bearings aren't just for giant machines. And this is where it gets really fascinating. The very same principles have been adapted for the most complex, most amazing machine of all, the human body.
You see this in partial knee replacements? Surgeons use this tiny, specialized, mobile plastic bearing to replace worn-out cartilage. And just like that, the joint can move smoothly and without pain again. It's literally a high-tech bearing inside a person. It's amazing.
But the challenges here are just immense, and they're deeply personal. I mean, unlike in a wind turbine, you can't just swap the part out easily. Failures like the bearing dislocating or the plastic material itself fracturing, these are common issues that mean more pain and another major surgery. Even microscopic problems, like something called stripe wear, where the tiniest error in surgical alignment can cause the whole thing to fail.
And this really gets to the heart of the matter. As incredible as bearings are, they aren't invincible. They wear out, they break down, and so predicting when that's going to happen has become one of the most critical jobs in all of modern engineering.
And the stakes just couldn't be more different. Like it says here, when a bearing fails in a wind turbine, that means expensive downtime. But when it fails in a knee, that means real human pain and more surgery. That huge difference is exactly why diagnosing failure ahead of time is so important.
So how in the world do you predict a failure before it happens? Well, in a way, engineers have learned how to listen for it. First, they attach these super sensitive sensors to a machine to pick up tiny vibrations. Then, powerful algorithms comb through all that data, looking for patterns that are totally invisible to the human ear. And finally, they train machine learning models to recognize the unique acoustic signature of a specific problem.
And we've gotten unbelievably good at this. By feeding enormous amounts of this vibration data to different AI models, from things like support vector machines all the way up to advanced transformers, we can now classify bearing faults with nearly perfect accuracy. This means we can often spot a failure long before it turns into a disaster.
But here's the thing. Even as we're perfecting how to predict failure, the real visionaries are already working on the next giant leap,
a future with almost no friction at all. What if the future of motion didn't involve any physical contact whatsoever?
The big shift, the real game changer, is moving from physical roller bearings to magnetic bearings. Think about that. Instead of using steel balls to minimize contact, magnetic bearings use powerful, precisely controlled magnetic fields to make a spinning shaft literally float in midair. There's zero physical contact, and that means friction drops to almost nothing. No wear, no tear, and no need for lubrication.
And the innovation, it doesn't just stop with magnets. Researchers are coming at this from every possible angle. We're talking about bearings that ride on a cushion of air, surfaces with microscopic textures that make lubricants work way better, even cryogenically treated steel that's unbelievably durable. It's all part of the same quest for perfectly smooth, perfectly efficient motion. And the real-world impact of this next-gen tech? It's already happening. For example, in those massive water chillers used for large-scale air conditioning, just switching from old-school bearings to magnetic ones has been proven to make compressors way more efficient. And you know what better efficiency means? Less energy used and a direct drop in greenhouse gas emissions. That's a huge win.
So from making our green energy future possible to actually helping repair our own bodies, the humble bearing is right there at the center of so much incredible innovation. It just leaves you with one final question, right? As our machines get smaller and faster and way more complex, how will these tiny, invisible titans of motion continue to reshape our world?